Hello students, in this lecture we will see how to draw the Bode plot, that is a magnitude and a phase plot for a particular factor given in the transfer function. Okay, so in last lecture I have shown you the standard form of transfer function. From that, what you need to do, you need to arrange the transfer function in standard form, that is 1 plus j omega form. Okay, then next thing is you need to substitute s is equal to j omega there. So see, actually I have taken some standard forms, Bode plot for standard factors. So first factor I have considered as a k, that is constant factor k. So look at this, what is our procedure? We need to calculate magnitude in dB. So how you will calculate magnitude? Magnitude, you know that you need to take mod. So look at this, first of all, suppose g of s is there, that is k, as constant term is there, there will not be s term here. So magnitude for taking magnitude in dB, you need to take 20 log of mod of j omega. So here magnitude it will be k. Okay, so look at this, magnitude m, it will be 20 log k, so this will be in dB. What about the angle? For constant term, angle will be 0, always 0. Okay, irrespective of the value of the omega, it will be constant, that is 0 degree. So what you need to do, you need to plot or you need to draw the Bode plot for the constant term. Okay, so look at this, now it will depend on the value of k. Okay, it will depend on the value of k. Suppose k is 10, so you need to take 20 log of 10 to the base 10. This is actually with decade, so you need to take to the base 10. Please remember. Suppose k is 100. Okay, so you need to take the value accordingly. So now what I am doing here, suppose I am showing here in the form of k, generalized form. Okay, so you can understand that it depends on the value of k, but minimum value it will be plus 20. Okay, and if this value is increasing, so this factor is also increasing. So see, my Bode plot for constant term, it will be always parallel to log omega axis. See, I have shown the semi-log paper here. On x-axis log omega axis is there, on y-axis I have taken the magnitude in dB. I told you that the scale it will be fixed 20, 40, 60, 80 like that. It depends on the number of pole, because each pole will contribute to line slope of minus 20 dB per decade. So this will be the positive value. Okay, and below 0 degree, see here 0 for y-axis and 0.1 for x-axis. So this value it will be always, I am showing that here it is parallel to x-axis. So see here I have shown this is m in dB. Okay, so this is, suppose my m in dB, you can check as the value of k is changing, so this line parallel to x-axis will change. Okay, next, second, g of s I have taken as 1 by s raised to power n, because I need to show the Bode plot for the generalized term. Okay, so this is a pole at origin, so n number of poles are there. So in last lecture also I have shown you the magnitude and the angle for 1 by s. So look at this, first you need to put s is equal to j omega, so g h of j omega it will be 1 by j omega raised to power n. Okay, shift it in the numerator, so it will be j omega raised to power minus 1 by n. But for Bode plot you need to take the magnitude in dB, so you will take 20 log of mod of j omega. So look at this, 20 log of here I have written, this is not mod. Okay, this is actually the same thing I have substituted here, but you can directly take the mod here instead of showing j omega, so there should not be any confusion. Okay, see here actually when you will take the magnitude, so I have shown you that under root of a square plus b square, a is 0, so under root of omega square it will be omega, so I can show here omega raised to power minus 1 by n. Then look at this minus 1 n is there, so log a raised to power minus b. So look at this, minus 20 n log of, here I will take directly the magnitude now. Okay, so instead of showing j omega, my answer it will be log omega. Okay, minus 20 n log omega. Okay, I hope you are getting. So depending on the poles at origin, you need to multiply. Suppose here n is equal to 2, that is s square, 2 poles are at origin. So my line slope it will be minus 20 into 2, so minus 40. Okay, suppose n is equal to 1, only one pole at origin, so this is minus 20. Then next you need to calculate the angle. For calculating angle, put again s is equal to j omega. You know that tan inverse of b by a is angle, but this part is in the denominator. So I have shifted. So my angle, it will be negative. So minus tan inverse of omega by 0. Look at this. B by a is 0. So I am getting here minus 90 degree for one pole. Okay. So for n poles, angle will be minus 90 into n. Okay. So I hope you are getting why I am saying that for pole the slope you know that m is equal to y by x. Okay. So see, my y is in dB and x is in decades. Okay. So line slope, it will be dB per decade. Line slope, it will be always dB per decade. So look at this, for pole your line slope, it will be always minus 20 n. Okay. Suppose n is equal to 1, that is one pole at origin. So line slope, it will be minus 20 dB per decade. Okay. For n is equal to 2, line slope is minus 40 dB per decade. Okay. Like that you can conclude. For angle, look at this, for one pole angle, it will be minus 90 into 1. So my angle, it will be always minus 90. For two poles, minus 90 into 2, so minus 180. Like that it will increase. Okay. Now see, I will plot the Bode plot for this. For that, again, what you need to do, you need to take a semi-log paper. On semi-log paper, select the proper scale for x-axis and the y-axis. So this y-axis is actually magnitude in dB. You can check here, I have taken the fixed scale 0, 20, 40, 60. Okay, so positive values will be upward and negative values will be downward, minus 20, minus 40, minus 60. So half portion of semi-log paper you will use for the magnitude plot and half portion you will use for the Bode phase plot. So see here, I have shown here actually this portion is I am using for the phase plot. So I am starting with the minus 90 because I know that the angle, it will be fixed, that is minus 90. Then for two poles it will be minus 80. So I can show here minus 80 like that. Okay. Now see, first of all, for one pole, look at this, for n is equal to 1, I need to show the line slope minus 20 dB per decade. Okay. So how I will show minus 20 dB per decade? Okay. For that you need to use a roller scale. I am using simple scale, but it will always be easy to draw the parallel line using roller scale. So please use roller scale for drawing parallel lines. Okay. So now see, my slope is negative. Okay. So slope should decrease, then only I will say that the negative line slope is there. Suppose line slope is increasing, so it will be positive. Okay. So what I will do, suppose I am considering this as a 0.1 here. Okay. Then my next decade, it will be 1, next it will be 10, next it will be 100, next it will be 1000. Okay. So look at this, what I will do for drawing the line slope of minus 20 dB per decade. Okay. So I will join this 20 and 1 line. Look at this. I am joining first decade. Okay. So 20 and first decade. Look at this. So this will be my line slope of minus 20 dB per decade. I hope you are getting. Okay. Suppose two poles are there, n is equal to 2. So you can check that minus 20 into 2, it will be 40. That is minus 40 dB per decade. So how I will draw the line slope of minus 40 dB per decade? For that I will just join the point, that is this 40 and first decade. Okay. So see how I am just joining. So this will be my minus 40 dB per decade. Okay. Then next, suppose n is equal to 3. 3 poles are there. So this will be minus 60, minus 20 into 3. So what you need to do, you will join 60 and first decade. So look at this. This third line is actually minus 60 dB per decade. I hope you are getting. So all these three lines are decreasing. So it will be having the negative slope. Okay. So see, actually this is, I will say, not with a proper scale. But when you will draw this magnitude plot on semi-log paper, so this line, it will be actually the parallel lines. Okay. So please use the roller scale and the semi-log paper to get the exact value of the gain margin and the phase margin. Okay. Now we will see the angle. So look at this. For n is 1, that is one pole at origin, my angle is actually minus 90. So how I will show? Minus 90 degree line is fixed. So minus 90, it will be, suppose I am taking this as a minus 90. Okay. So the angle line, it will be parallel to log omega axis. So look at this. This portion is for magnitude and I have started with minus 90. So next point, suppose next division I am taking as minus 180. Suppose two poles are there, so angle will be minus 90 into 2. So I will show like this. Okay, I will draw the line with minus 180 degree, that is parallel to log omega axis. Okay, so I hope you are getting. This is the way you need to draw the line with proper lines, slope and angle. Okay, now next we will see for 0 at the origin. See, these are the basic factors I have considered. In next class I will actually show the table, okay, for magnitude and angle directly, and after that I will directly show the procedure. So please see properly how I am drawing. 0 at origin. Okay, so gh of s, I have taken s raised to power m. So substitute s is equal to j omega. So next I can write j omega raised to power n. So what I need to take magnitude in dB. So how I will take 20 log of mod of j omega. Okay, first of all look at this. You need to take mod of j omega. So mod of g of j omega. Okay, so what will be my magnitude? Magnitude, it will be omega raised to power m. Okay, so like that this is my magnitude. I have taken 20 log. So 20, look at this, omega raised to power m is there. When I will take the log, so I can write like this, 20 m log of omega to the base 10. So I will get dB. Okay, now for angle of j omega is equal to, look at this is in the numerator part. So tan inverse of b by a is 0 here, so omega by 0. So for 1 0 I am getting angle of plus 90 degree, whereas for for pole I am getting angle of minus 90 degree. Okay, so when I will multiply, here I should take m because for pole I have taken n. Okay, so this is 90 degree into m. It depends on the number of zeros. For 1 0, your line slope, it will be always plus 20. Look at this, plus 20. Okay, then angle is always plus 90. For 2 zeros, it will be 20 into 2, so plus 40, and it will be 180 degree. Okay, like that you can draw the conclusion. Now the important thing, now I need to show look at this, for m is equal to 1. My line slope is 20 dB per decade, plus 20 dB per decade. For m is equal to 2, I need to show 20 into 2. So this will be 40 dB per decade. Okay. So similarly, you can increase, and angle it will be. So I am showing the angle here. Suppose phi for m is equal to 1, I am getting 90 degree. Then next it will be 180 degree, like that. Okay. So first of all, I will show the line with line slope 20 dB per decade. Okay. So plus 20 is there. So again what I will do here, point 1 is there. So 1, 10, then 100, like that. Okay. So for drawing the line slope with positive value, it should be increasing. So what I will do, look at this. Now I will just draw the line with minus 20 and 1. Okay. So look at this. I'm joining this minus 20 and 1 line. Okay. So this is my line slope plus 20 dB per decade. I hope you are getting. Okay. For drawing next plus 40 dB per decade, I will join 40 and 1. So look at this. So next line is plus 40 dB per decade. Okay. For 3 zeros, next it will be plus 60 dB per decade. Okay, so this third line is plus 60 dB per decade. Okay, look at this. This is with negative line slope, this is with positive line slope. What about angle? Here already I have drawn the line. For m is equal to 1, you are getting 90 degree. For m is equal to 2, you are getting 180 degree. So this will be the angle line with 90 degree, this is with 180 degree. Okay, so I hope you are getting how to draw the line slope. Okay, in next class I will actually show the factors. Thank you, students.